So hello everyone. So in this video we are going to talk about data frames that are present in Python, right? So in the previous video we talked about series data structure. So as we remember, Python pandas library basically offers two data structures which are pretty used, the series and the data frame. Of the series and the data frame is the most used and most studied also. The reason being, you see, the very purpose of using pandas is for data analysis, and real life data is basically two-dimensional. That means each and every data point is being represented by row and column, right? So imagine a school report card or the collection of all the marks, right? So all marks of a school exam, right? So we can have a roll number, we can have name, then we can have marks, right? And we can have maybe class, right? And in this way we can have all the rows, row 1, row 2, row 3. In this way it keeps on going. So based on this particular data we can perform some sort of an analysis. Okay, so even in real life most of the data is stored in some sort of a comma separated value or in a relational table maintained, right? So for that we need a mechanism or a data structure that can hold this two-dimensional data. So for that we have data frame. Now data frame is a two-dimensional data structure offered by pandas that can be used to store 2D data. Does it make sense? So as we can see, it can load or it can work with data from spreadsheet application like MS Excel or. So now let us talk about some of the features of a data frame. So we'll talk about some of the features of the data frame and then we'll move over to construction of a data frame, right? The first point is two-dimensional. So obviously a data frame is a two-dimensional structure, and because of that it can actually hold two-dimensional data from maybe a spreadsheet application, maybe an SQL database. The size is mutable and data is mutable, right? And it is of heterogeneous tabular data structure. It's a heterogeneous tabular data structure. Now what does it mean? Suppose I have three columns in here, C1, C2 and C3, and I have a row 1, row 2, row 3. Now what data frame allows us is that each of the column can have their own individual type, right? So they are not linked. So suppose C3 is a string, C2 is an integer, and C1 may be a float, something of that sort, right? So now within a same data structure we can have different types, a string, an int and a float. But the thing is that's why it's a heterogeneous data structure. But the thing is that within the column, right, within the column the data type should be same. Does it make sense? So all the elements in the C1 column should be of float type, all the elements in C2 column should be of integer type, and all the values in the C3 column should be string. So that is what it is. That's why it's called a heterogeneous data structure, right? So data is identified using rows and column indexes, right? Because it's a two-dimensional structure, and we know that a 2D structure, in a 2D structure the data is accessed via two values or maybe index values, right? So these are row value and column value. Now if you have worked with some sort of spreadsheet application, MS Excel or something, so you know that each of the cell is being identified by some sort of a row column identification, like A1, A2. In this way it keeps on going, like A22, something of that sort. Okay, so first maybe column name and the next maybe row name, in that way. Does it make sense? Now in data frame, axis 1 denotes it's a column and axis 0 denotes it's a row. Now at certain functions and code we do use the axis argument, so it's better to know about it. Again, axis 1 means column and axis 0 means row, right? Now indexes can be string, numbers, letters, whatever. Indexes means the name of the column, the name of the row. Those are called indexes, right? So now as we discussed that same column should have data of same type. This is mandatory, but different column can have data of different types. Now another important thing is that making plots. Now from the data frame itself we can make plots. Now what kind of plots we are talking about? Line chart, bar chart, pie chart, right? We can also calculate box plot with mean, median, mode and everything, right? So, and it can be thought as a dictionary of series object. Now we do know that a dictionary is a collection of key value pair. Now these collection can be series object, right? And we'll see how to actually create a data frame out of a dictionary consisting of series objects, right? And another important thing that we have to remember is that pandas library has to be imported to create a data frame, and it is obvious. During our video on series object, the series data structure, we had to import pandas library in order to make it work, right? Now this is an example of a data frame, right? So here C1, C2, C3, C4, C5 are column names, and these are the index labels, right? 1, 0, because we didn't provide any index label, so that's why by default it starts from 0 and goes all the way to n minus 1. Again, column is being considered as an axis equal to 1, and axis 0 means row. Now this is a collection of data, again heterogeneous data structure. We have string, we have floating point number, we have integers, floating point number, integer of some sort, right? And nan means not a number, right? So nan basically means missing data. If our Excel sheet or wherever or whatever we have actually fetched in our data, if the data is missing for a particular column, in that scenario it will be filled with a NaN, that is not a number. And it's a good mechanism because it doesn't throw an error. Even if the data is missing, it will not throw an error. It will actually create the data frame with the missing data. And later on, pandas does offer mechanism through which we can handle this missing data. We can clean it up or fill up with some sort of a value, or based on the consecutive or the surrounding values. Based on that we can do it, right? Take an average or some sort of thing, right? So NN basically symbolizes the missing data, right? So we gave an example of a 2D frame. Now this is the important part where we talk about creating a data frame. Now this is the general syntax. Now pandas library has to be imported, and because of that, pandas, then data frame. Now here we have to observe that D is capital, F is capital. Like in series object, for creating a series object, the S should be capital. So in case of data frame, D and F both has to be capital. Now by default, all the arguments that we see over here, right, are assigned none. That means we can create a data frame just writing data frame with empty brackets or parentheses, and it will create an empty data frame. But most of the time we are going to use the data keyword argument, and we will provide some sort of a value to it, maybe a list, maybe a numpy array, maybe a dictionary, and usually dictionary is being preferred, at least for our examples. Or we might even provide a link to some sort of an external file, maybe a CSV file or a table or some sort, right? So in our blog post you can read about all of this. The arguments details are given. Now data is actually the argument which takes the data for creating our data frame. Index are basically the row names, right? Labeling for the rows, and columns provides labeling for the columns. So as you can see in this particular example, we had column labels. Now this can be achieved by providing a list of values in the column argument. So we'll write something of column is equal to within a list, because we cannot just provide individual elements. We have to provide some sort of an iterable object. So C1, maybe C2, right, C3, C4, something of that sort, right? And actually we'll get something similar.